Good afternoon, grade 12 learners. Welcome to our physical sciences chemistry session. My name is Tandwe Uwane. This lesson is proudly brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Phakama Research and Development. Our today's lesson is going to be based on our half-yearly examination, meaning that we are going to try and revise all that we did since the beginning of the year up to now, so that we can see what is it that we are expecting on Monday, the 13th of June, as we are going to write our half-yearly examination. So I will try by all means to make sure that I cover up most of the questions that we have done in order for us to be able to make sure that you remember what we have done already at the beginning of the year. Now, this is the structure of the question paper, or these are the topics that we are expecting to find at the end of the year, by the lesson that you're going, the paper that you're going to get in on Monday. The first question is going to be question number 1, which is going to be our multiple choice questions. We know that when we look at the multiple choice questions, we look at the questions that are always providing us with 2 marks. So it is very important that when you deal with multiple choice questions, you deal them with a very sincere care so that you are able to get those 2 marks. Then we are going to look at organic molecules, which is going to be our question number 2. And then also question number 3 is going to be organic molecules, and question number 4. So as you can see from the structure of the paper, question number 2, number 3, and number 4, they are all going to be part of the organic molecules. So it means organic molecules takes a lot, or a high weighting in terms of the paper that you're going to write on Monday. So it means you must definitely study hard in terms of understanding organic molecules. Then question number 5 is going to be rates of reactions. And number 6, chemical equilibrium. And the last one is going to be question number 7, which is acids and bases. So what we are going to do, we are just going to try and check what is it that we have done in all the topics that I've already stipulated on our structure of the question paper, as you are going to see it on Monday, the 13th of June, 2022. Now, let's start with our multiple choice questions. What is important about the multiple choice questions? All topics are examinable on the multiple choice questions, meaning all the topics that I've already outlined as the structure of the question paper, they will be found in our multiple choice questions. Therefore, you must make sure that when you look at the multiple choice questions, make sure that first thing that you check whether in which topic does this specific topic is coming from, so that you can just try and put your focus on that specific topic, or you can tune your mind in that specific topic. Then each question consists of 2 marks. There are a special consideration to be given in these questions. As I said at the beginning, multiple choice questions will always be granted or awarded 2 marks. Therefore, it is very important that you don't just choose any option. You must look thoroughly to your options. You must check thoroughly your distractors, so that at the end of the day, whatever answer that you choose under your multiple choice, you choose it carefully. They are normally not easy questions, of course, because you are provided with answers, and some of the answers are not relevant for that specific question. Therefore, you must always make sure that you choose the best option for that specific question. Therefore, it is very important that for you to get that 2 marks for multiple choice, you thoroughly look at the question and you choose your options correctly. Identify to which topics does the question belong in order to collect all facts, as I said. Thoroughly analyze the question before attempting to choose. Like, before you choose any option, don't just say A, B, C, D, because we normally provide you with 4 options, and then you just choose any option. As I said, thoroughly check whether that option is the best option. Minimize the distractors in order to be easy to choose from the 4 options provided. As I said, all our multiple choice questions will be provided 4 options, and there's always one correct answer from the 4 options that are provided. So try and minimize the distractors as much as possible for you to be in a position to be able to answer or to choose the correct answer. Now, when we are going to look at different topics, we are going to start with our organic molecules. These are the examinable terminologies that you can find in organic molecules. However, these are not the only examinable terminologies that the examiner can ask in terms of the organic molecules. Therefore, as a starting point, I think it is very important to understand the following terminologies that I'm going to discuss. Remember, all the terminologies that I'm going to discuss with you, they are there in your exam guideline. So if you want the definitions or if you want to revise the definitions, you go straight to your exam guideline, you check those definitions. Now, let's look at the definitions that I have chosen for you to be able to remember what is it that we have done under organic molecules. We look at homologous series. Remember, there were 9 homologous series that we looked at as we started. And it is very important to understand what is a homologous series. So as I said that a homologous series is a series of compounds which have a same physical and chemical property. And each member differs from the other member by CH2. So it is very important that you go to your exam guideline, you also thoroughly recall or remember the definition. What do we mean by a homologous series? As I said, there were 9 homologous series that we dealt with, and all of them you must remember them, and you must remember them in terms of their functional group, which is the second terminology that we need to remember in terms of the homologous series and also organic molecules. So what are these functional groups? Remember, the functional groups are also giving the characteristics to a homologous series, meaning that they are giving the chemical property to or the physical property to a homologous series. Therefore, the definition of functional group, as it is provided to you on your exam guideline, it is very important that you also go to it, revisit it, and recall it, because you are not going to be provided the exam guideline during the examination, but you have to recall the definitions that you are provided on your exam guideline, the way they appear on your exam guideline. Then you also need to remember what we mean by saturated and unsaturated compounds. Remember, saturated compounds, as we explained them, those are the compounds which have only single bonds between the carbons, or they have single bonds only. The examiner will always accept when you say single bonds only, because it shows that as you are saying it is saturated, it means there are no other bonds or multiple bonds that you are going to find in that compound. So single bonds only, or they have single bonds between the carbon atoms. Those are the compounds that are represented as saturated. And then unsaturated, those are the compounds that have multiple bonds. And as we further explain the saturated and unsaturated, we also explain how do we test for saturation. I think this one you remember when we're doing test for saturation. And then I said for us to test for saturation, we use what we call bromine water. If the color of the bromine water, like if the color of the bromine water decolorizes, as one thing that you need to remember, as the color of bromine water decolorizes, it means that substance or that compound is unsaturated when there's no heat or light involved. However, if the bromine water it doesn't change, the color doesn't change, it remains brown, it means that specific substance is saturated. So bromine water is a substance that we used to test for saturation to see whether a compound is saturated or unsaturated. And the color of the bromine water is an indication that we have used to say if the color of the bromine water, as it is brown in color, it decolorizes or changes the color or becoming colorless, or the color fades away, it shows that the substance that is reacting with bromine water at that instant is unsaturated. However, if the color of bromine water doesn't change, it remains brown, it shows that that substance is saturated. We will look at what makes the color of bromine water to decolorize when we look at the reactions. But it is very important to know how do we test for saturation, because that is an examinable concept also, to test for saturation. We also looked at isomers. We also look at different isomers, which is what we are also going to revise today. We looked at functional isomers, positional isomers, and chain isomers. And we also looked at the names of the functional groups. And we said the name of the functional group given to the alcohols is hydroxyl group. The name of the functional group given to carboxylic acid is carboxyl group. And then ketones is carbonyl group. And aldehydes is formyl group. You can just put group here, because these are the names provided to different functional groups. So you need to also remember the names of different functional groups that was provided to you when we are dealing with organic molecules, because these names can be asked under your multiple choice or can also be asked under structured questions. So it is very important that you remember the names, because there are those functional groups that are provided special names like this one. For the alkenes, you know, it's the double bond. For the alkynes, it's the triple bond. However, those are not names. They are just the bonds that are being shown to those compounds to say how do we identify them. But the carbonyl, for the ketones, the formyl, for the aldehydes, the carboxyl, for the carboxylic acid, the hydroxyl, for the alcohols, definitely they need to be remembered, because they are the names that are specifically given for the specific functional groups. Now, as I said, I will just take you through the recalling in terms of the isomers as functional isomers, positional isomers, and chain isomers. Remember, as I'm starting with the functional isomers, we know that functional isomers, all isomers have the same molecular formula. So what is important about the word isomer is that all those compounds that we will be comparing, they have what? The same molecular formula. So the first word that we'll start with, as you are identifying all the isomers, whether chain, functional, or positional, the first sentence that we're going to write is that it are compounds with the same molecular formula. I think by now we know what we mean by molecular formula. We know what we mean by structural formula, and we also know what we mean by condensed or semi-condensed formula. So it is very important that you know that if you are saying these compounds, you are classifying them as isomers of either a form, you must know that they must firstly have the same molecular formula. Now, if you look at the functional isomers, we know that functional isomers, we have ketones that are functional isomers of aldehydes. And we have what? We have esters that are functional isomers of carboxylic acid. So therefore, it means when an examiner can give you a ketone and say, write or draw the structural isomer, or the functional isomer of this specific ketone, actually the examiner is instructing you to draw the structure of an aldehyde from the same structure of the ketone that is provided. Or if you are provided with an ester and then the examiner say, draw a structure or the functional isomer of an ester, the examiner actually is saying to you, draw a carboxylic acid from this specific ester. So it is very easy to move from a ketone to an aldehyde, and also from an ester to a carboxylic acid, because you will just count the number of carbons for that ketone. For example, let's say if I'm having a ketone, as I'm going to remind you about such terms, I'm having a ketone, maybe this butane-2-one or butane. This is the structure of a ketone, butane-2-one. Then, if I have to draw a structure of a functional isomer of this butane-2-one, the only thing that I will just start to think about is that from a ketone to a functional isomer of a ketone, I know that I must draw an aldehyde. So I will just count to say 1, 2, 3, 4 carbons in this ketone. Therefore, if there are 4 carbons in the ketone, it means I need to draw an aldehyde with 4 carbons. And that aldehyde will be a butanol. 1, 2, 3, 4. And then I just draw a structure of a butanol. Okay, there's no need for an H here. So this is an example of functional isomers. Why do we refer to them as functional isomers? Remember, functional isomers have the same molecular formula but different functional groups, or they belong to different homologous series. Therefore, as you know that this is a ketone and then this one is an aldehyde, they will both have the same molecular formula, which is 1, 2, 3, 4, C4, 1, 2, 3, 4, 5, 6, 7, 8, H8, and then O. Even this one is 1, 2, 3, 4, 5, 6, 7, 8, C4, H8, O. So when you look at their molecular formula, they have the same molecular formula, but what you know is that they don't belong to the same functional, they don't belong to the same homologous series, or they don't have the same functional group. So that is why we call them functional isomers. And then we also talked about positional isomers. So you can see that already when you talk about functional isomers, they must belong to different homologous series, because they will have different functional groups. However, if you look at positional isomers, the first thing that you need to know is that positional isomers, they belong to the same homologous series, meaning that they will have the same functional group. But the only thing that you're going to do, you're going to move the position of the functional group. Like in this case, if you are looking at the example of a positional isomers, we can talk about but1 in and but2 in. So these are the end. Make sure that whenever you are drawing a structure, especially where there's a double bond or a triple bond, you always count the number of bonds around each carbon so that you don't have extra bonds. So if you look at this one, is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So this is but1 in, and then if you draw a but2 in, which is a positional isomer of but1 in, you will have something like this. Remember, these are called what? Positional isomers, because they have the same molecular formula, but the position of the functional group is not the same, because this one is but-1 in, and this one is but-2 in. So they are positional isomers. They belong to the same homologous series. However, their position of the functional group, as you look at them on the structural formula, they are not in the same position. So that is why we refer to them as. And then the chain isomers, we know in this one, the other one will form maybe a straight chain and the other one will be branched, or the other one will be more spherical or more branched than the other one. However, they will have the same molecular formula but different chain length. So this is what I wanted you to remember. Like for example, if you have a butane as a structure, and then we know that this is butane, which is C4H10. If you want to draw a structure of, if you want to make a chain isomer of butane, you just reduce the chain. The longest chain was 4. You just gonna make it 3 like this, and then you introduce a branch, and then you're gonna find a methyl propane. So when you look at butane and methyl propane, they are what? They are chain isomers because they both have C4H10 as their molecular formula. However, the longest chain, and this one is 1, 2, 3, 4. However, this one is 1, 2, 3, or 1, 2, 3, or 1, 2, 3. So you can see that this is a chain isomer of each other. They are chain isomers of each other. So always when you talk about isomers, you talk about 2 or more compounds that you are comparing in terms of their structure. But you need to say what makes their structure to be different. Is it their functional group? Is it their chain length? Or is it about the position of the functional group? So that you classify them as chain or functional or positional isomers. However, what I want you to remember is that the first part, same molecular formula, will be applicable to all of them. Now, when you look at the physical properties, we know that physical properties will probably be our question number 3 of the examination. It's where now we are looking at the physical properties of these organic molecules. We know that we have 3 dependent variables which will depend on the independent variables. So what is important is that under physical properties, you need to be able to identify your dependent and your independent variables. What do we mean by dependent variables? The dependent variables that we are going to look at, because those are going to be affected by the independent variables, which are our physical properties, is the boiling point, is the melting point, and the vapor pressure. Now, what is the first thing that you need to know about these quantities or these variables? We need to know their definitions. Remember or recall the definition of boiling point, of melting point, and vapor pressure. You will not know which one will be examined during your June or your final exam or your prelim. So it is very important that you know all of them. Boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure. Remember, this definition is provided to you on your exam guideline. Melting point is the temperature also at which the solid and the liquid phase of a substance are at equilibrium in a closed system. And then vapor pressure is the pressure exerted by vapor at equilibrium with its liquid in a closed system. So all the 3 definitions, they must be known before you go to your examination, because you need to know all of them. However, most of the time, the examiner will just require one for you to define during your examination. Therefore, remember all the physical properties. As I said, all of them as our physical properties, they are also referred to as our dependent variables. What are these variables depending on? These variables will depend on the chain length of the compound or the surface area, or we can say how much is branched or unbranched is the compound. And the last one is the type of the intermolecular forces. So these three, the chain length, if you change the chain length, definitely you can affect the boiling point or the melting point or the vapor pressure. If you change the surface area, like the example of butane and methyl propane, as we have seen it as chain isomers, you know that definitely as a butane and methyl propane, they will not have the same boiling point, melting point, and vapor pressure, even though they have the same molecular formula as chain isomers. So you need to know the relationship between the boiling point with the chain length with the surface area, and also the chain length with the type of intermolecular forces. Let me start by looking at the chain length. When you look at the chain length in terms of the boiling point and the melting point, we know that the longer the chain, the higher the boiling point, the higher the melting point. So we know that if you are comparing, for example, methyl propane and butane, you know that butane will have a longer chain length. Therefore, it implies that butane will have a higher boiling point and higher melting point. However, the boiling point and the melting point, they will be the opposite of the vapor pressure. Therefore, it means if you have a higher boiling point and the higher melting point, you will have a lower vapor pressure. Therefore, the relationship between the chain length and the boiling point and the melting point is that the longer the chain, the higher the melting point, the higher the boiling point, and the lower the vapor pressure. That is the first thing that you need to remember. And also, when you look at the surface area, so we know that the longer the chain, the higher the boiling point, the higher the melting point, and the lower the vapor pressure, which is the opposite with the shorter chain length. And then surface area, the more branched the surface, or the larger the surface area, the larger the surface area, the larger the surface area is the same. The higher the boiling point, the higher the melting point, the lower the vapor pressure. Therefore, if you compare in terms of the boiling point or the melting point of methyl propane and butane, you will see that butane will have a higher boiling point and a higher melting point. However, methyl propane will have a higher vapor pressure because it will have a lower melting point and a lower boiling point. And then in terms of the type of intermolecular forces, we need to also remember that, let me just go back, we'll go to it. We also need to remember the table that we provided that was classifying different types of intermolecular forces and different homologous series that are falling under those homologous series. So we're going to look at that table at the later stage. But what is important is that you need to know whenever an examiner is giving you a question under the physical properties, you need to be able to identify the dependent variable and your independent variable. Just make sure that you see what is it that the examiner has manipulated in the structures or in those compounds for them to not be the same or for them to be the same, so that you can see whether the test that you are provided in those compounds is a fair test or what. Because if it can happen that an examiner gives you more than one variable or one independent variable to test on, that is not going to be a fair test for you, because you will not know where to stick on. It's either you stick on the chain length or you stick on the type of intermolecular force, which is homologous series, or you stick on the surface area. So when there are more than one independent variables in an experiment, that experiment will definitely not provide a fair test to you, because you will not know what is it that we are definitely comparing. Then remember, we also look at the IUPAC naming of these compounds. And what was important is that Before we look at the IUPAC naming, we started by making sure that we identify those compounds. We identify those compounds using different suffixes. We also identify them using different functional groups. Now, we remember that we were having 9 homologous series. ANE was the suffix for the alkanes, ENE for the alkynes, YNE for the alkynes, all for the alcohols, al for the aldehydes, on, some will say 1 for the ketones, oic acid for the carboxylic acid, and OAID for the esters. Now, remember, whenever you name a compound, you need to firstly identify the parent. Where does that compound belong to? In which homologous series does that compound belong to? Because you cannot name something that you cannot identify. So naming will definitely start with the identification of those compounds to say in which homologous series do they belong to. Now, we also use the structure of the functional groups to identify the compounds. It is very important to know the structure of the functional groups. And the structure of the functional group, they are provided to you in your exam guideline. I also just try to snapshot these structures of the functional group so that you know exactly what we mean by the structure of the functional group. When you look at the structure of the functional group, we are having the alkanes, which have the single bonds only. We are having the alkenes with the double bond. But we can see that we are not including the hydrogens as we are drawing the structure of the functional groups, because we are just identifying to say, if you are an alkane, you will have this in common. Because if you include the hydrogens, you are now naming an alkane. But in this case, we are not naming, we are just indicating how will the structure of each functional group look like. The triple bonds for the alkynes, we have the haloalkanes, where X represent our halogens, which are the elements in group number 7. We have the COH for the alcohols. Make sure that always when you draw the structure of the functional group, you also make sure that the number of bonds around each carbon, they are always 4. It doesn't matter whether you are not including the hydrogens, but make sure that the number of bonds around each carbon are always 4. So these are the examples of the structure of the functional group as they are stipulated on your exam guideline. We also have aldehydes, ketones, carboxylic acids, and esters. So you can recall these structures by knowing how do you draw them, so that they can also assist you when you draw different compounds to be able to remember how do you draw a specific compound in a specific homologous series by remembering their functional groups. So these functional groups are very important. They need to be known in terms of their names and their structures. We started by looking at their names, like alcohols. This, it means it's our hydroxyl group. And then this one is our formyl group for the aldehydes. This one is the carbonyl group for the ketones. This one is the carboxyl group for the carboxylic acid. We don't have the name specifically provided for the esters because they just use an ester bond. But we have some of the functional groups that are provided names. So you need to know the name of the functional group and the structure of the functional group as given to you on the exam guideline, exactly as it is, because this is the way I took it from the exam guideline. And also, as you are going to name, you know that the first thing that you are going to do after identifying the homologous series in which that specific compound belongs to, you are also going to look at the longest chain. So you are going to identify the longest chain. When we identify the longest chain, we know that the longest chain that is examinable in physical sciences, according to the exam guideline, we start from number 1 up to number 8, whereby 1 is indicated by meth, 2 eth, 3 prop, but for 4, pent for 5, hex for 6, hept for 7, and oct for 8. So we know that the first mark that the examiner can give you is when you have identified the homologous and the longest chain, meaning that if you say it's an octane because it's an alkane and it's having 8 carbons in the longest chain, then that is a mark because you're able to use a skill to identify that homologous series and the longest chain. So the first thing before you name anything, you need to firstly identify the longest chain, and you also need to also identify the homologous series or the functional group in which that specific compound belongs to, so that you can use the correct suffix, because the suffix are the ones that are going to identify in which homologous series does that specific compound belong to. The next thing that you're going to do now, you're going to number your carbon. Remember, you have identified the homologous series, you have identified the longest chain, then you can start numbering. Remember, numbering will depend on the substituents that are provided to you and also the functional group that is provided to you in that structure. So numbering of the carbons will always take preference in terms of the functional group if you have one in the structure. However, when you're naming haloalkanes, because haloalkanes are not classified as the halogens as their functional group, therefore, that is why when naming haloalkanes, there are lots of rules that we are going to use. And we also discussed those rules in our previous lessons to say, how do you identify or how do you number your carbons looking at the substituents that were provided in that specific compound? Then, how do you write the name now is also very important, because whatever that you are going to write will definitely award you marks according to the specifications on how do we do IUPAC naming, because this is a system of naming that is internationally recognized. Therefore, you need to name in a specific way. Like, for example, if you are using a hyphen when you are having a number and an alphabet, I think we know what do you mean by numbers and also what do you mean by alphabet. If I say 1, 2, 3, I mean numbers. If I say A, B, C, D, I mean alphabets. Therefore, it is very important that when you separate a number from the last letter to the number, you use a hyphen. However, if you have two numbers that are following each other, you are going to use what? A comma. So you will see that some of the compounds, as we are naming them, we are using hyphens. Sometimes we are also using commas, because as numbers are following each other, we always put a comma. And then we normally leave no space if there are two alphabets following each other. However, we are not, the examiner sometimes is not so strict in terms of that, because sometimes the writing can also be messy, so that we don't even see whether there's a space between those compounds or what. However, in terms of esters, normally we name esters because they are coming from two different homologous series. We name them as two words because they are coming from alcohols and carboxylic acids. So normally we leave space when we are naming esters. And then all rules of naming are provided in the exam guideline, as I'm saying. So make sure that, especially in the terms of the naming of the haloalkanes, you also like consult your exam guideline and check how do we name those haloalkanes. Let's look at this example. I just chose this example so that we can remember how do we name, and we can also revisit whatever activities that we have done previously so that we remember how do we name. Write down the IUPAC name of the following compound. Now, as I said, the first thing that we are going to do, we are going to identify the longest chain. Now, by identifying the longest chain, we are now trying to make sure that you are choosing the correct prefix, whether it's a meth, eth, prop, but, pent, hex, hept, or oct. So you need to identify the longest chain. You cannot start by numbering your carbon first before you identify the longest chain, because the longest chain will normally refer to it as the parent of the compound. Therefore, the parent chain is the one that is important. But we can see that this structure is provided as a semi-condensed structure. If maybe you feel that you are sometimes frustrated in terms of working with the semi-condensed structures, you can uncondense it and make it the structural formula so that you can be able to see those branches and also to be able to identify your longest chain. If we condense this structure, the first thing is CH3. The next carbon is C, and then there's a Br at the top, and there's a CH3. We can uncondense it. And then the next carbon is CH2, followed by CH, and then there is another CH3. So I'm just uncondensing it so that, and then C, and then CH3. Let me just write it at the top as it is. And then there is an H, and then the last one is CH3. So sometimes when a structure is like this, is uncondensed, you are feeling a little bit comfortable to identify your longest chain, because you will see what is each carbon bonded with. So if you look at our condensed or uncondensed structure, you can see now we start to identify the longest chain. We can start with a straight chain. Normally, we normally start with a straight chain. 1, 2, 3, 4, 5, 6. Or we can use another route to identify the longest chain. 1, 2, 3, 4, 5, 6. Or we can use 1, 2, 3, 4, 5, 6. If I say 1, 2, 3, 4, if I say 1, 2, 3, 4, 5. So if I look in all directions, whether it's a straight line, whether I use this as my chain, or whether I use this as my chain, where is it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. All of them, they are giving me the longest chain as 6. And I know that this is a haloalkane and it's a hexane. So the first mark that the examiner can provide me is when I have identified that this is an hexane. I get 1 mark because I've identified the longest chain, and I know that this is a haloalkane. So it's an alkane with a bromine, so it's a haloalkane. So hexane will be my first. Then the second thing, now I must number my carbons. Already, if I'm choosing this as my longest chain, it means, let me see if I cannot get another color so that I can just, I want to identify, okay, let me just see. Okay. I can see, okay, I'm unable to choose a color. I will see whether I can do it for the next one. I can see that I'm having my branches, which are my substituents in this regard. Therefore, because I've identified my longest chain and then now I've also identified my branches, then it means the next thing that I have to do now, I have to number. So if I start at this side, I'm having number 1, number 2, where I have a methyl and a bromine, which is a bromo. And then there's another methyl here. There's another methyl. So already I have seen that I'm having 3 methyls. So immediately when I'm having 3 methyls, for the 3 methyls, I know that I now have trimethyl, which is the next thing that I know about my structure and a bromine. Now, if I say I start this side numbering is 1, 2, 3, 4, 5, 6. So I'm finding my bromine in carbon number 2, and I'm also finding my methyl in carbon number 2 coming from this side. However, if you look at this carbon number 2 as compared to this carbon number 2, you can see that this carbon number 2 is mostly substituted, meaning that it is having 2 substituents as compared to this one. Therefore, in order of preference, I will definitely prefer the carbon which is mostly substituted. Sometimes it cannot be this carbon which is mostly substituted, but it can be the side which is mostly substituted. So if I look at this side, I can say it's 1, 2, 3, 4, 1, 2, 3. But if I look at this one, it's in carbon number 3. In carbon number 3, this side, I don't have anything. But this carbon is mostly substituted as compared to this one. Therefore, it means my number will be this one, which is going to be, let me try again. Which is gonna be, as I think I've won in terms of the coloring, because you can also do this during your examination so that at least you know that you are using the correct colors. Therefore, it means now I'm going to choose, let me just go back to my red for naming. So therefore, it means now this is gonna be my numbering 1, 2, 3, 4, 5, 6. Therefore, in carbon number 2, I have seen that I have a bromine and a methyl. In carbon number 4, I have a methyl. In carbon number 5, I have another methyl. So if I'm naming now, I know that I will name alphabetical order. I will always start with a bromine followed by a methyl. So the name of this compound is going to be 2-bromo-. Therefore, I'm having in carbon number 2 and in carbon number 4 and in carbon number 5, I have methyl. So it's going to be 2, 4, 5 dash trimethyl. Remember, I have identified it as a hexane. It might happen that sometimes when you are numbering, you forget which side you have to start to in terms of whether mostly substituted or whatever. Maybe let's say we started numbering from this side. Let me just use another different ink. Maybe let's say we started from this side, and then we said is 1, 2, 3, 4, 5, and then 6. It means our name was gonna be, because now our bromine is carbon number 5, was gonna be 5 dash bromo, and then dash. So we have methylene carbon number 2, in carbon number 3, and then in carbon is number 2, number 3, and number 5. So it's gonna be 2, 3, 4, 1, 2, 3, yeah, 2, 3, 5 trimethyl hexane. For the two names, let me just assure you, for the two names, you will get 2 marks, because you'll get 1 mark for the hexane, which is the longest chain. You will get the second mark for identifying all the substituents that are provided to you including the word trimethyl. However, now let's check in terms of the numbering. The numbering of this one is 5, 2, 3, 5. Now, if you're having such a dilemma, you just add the number of your substituents. The one that gives you the small number, that will be the correct one. Meaning that I will say 2 plus 2, which is 4, plus 2, which is 8, plus 2, which is 13. This one is going to be 5 plus 2, which is 7, plus 3, which is 10, plus 2, which is 15. So you can see that 13 is smaller than 15. Therefore, that is why the first option is the correct one. So whenever you feel like you are frustrated in terms of the option, just go back and remember that we use an addition of a substituent issue in order for us to decide which option is the correct one. Then, as I said, that when we are going to explain our physical properties, we are going to look at the strength of the intermolecular forces, the energy needed to overcome those intermolecular forces, because it is very important that you know how do you respond in terms of the physical properties, the one that we just discussed. And I also said we are also going to look at the table that also provides you with the different intermolecular forces on how to answer physical properties. As you know that this falls under London forces, which are our hydrocarbons, which are compounds of carbon and oxygen. And then we have the dipole ones, which are aldehydes, ketones, and yellow alkanes and esters, and the hydrogen bonds, which are one side of hydrogen bonds for alcohols and two sides of hydrogen bonds for carboxylic acid. My learners, what we are going to do, before we go for the reactions, I just want us to have a 2 minute break, just to absorb whatever that we just discussed, just for 2 minutes, to just drink water, and then we are going to continue from there up to the end with our revision, as we are going to start with our reactions under homologous series, which is going to be the last concept under homologous series, which are organic reactions. So for 2 minutes, we'll just have a little break, and then we will come back and continue with our revision for paper 2. Welcome back, grade 12s. I hope you have just rested a little bit because today's lesson actually is including most of the concept that we have done. I know it might sound very much exhausting, but we'll try by all means and make sure that we tap in all the topics that we are going to talk about or that we are going to write about when we come to Monday examination, which is our chemistry paper, paper 2 of 150 marks for physical sciences. Now, the next thing that we have done under organic molecules are the reactions. Now, it is very important to remember the types of reactions that we have done. No examiner will ask you what is the type of reaction that we have done. However, they might sometimes provide you with an example and ask you identify the type of reaction that you are given, or what is it that you was added, or what is it that was removed in the specific reaction. So it is very important that you remember all the reactions and exactly what we have done under those reactions. So we looked at the combustion of alkanes. As I said, that we are going to look at the reaction of alkanes with oxygen. We know that our oxygen is O2, so it is very important that always when we say a specific substance react with an alkane or with oxygen, you know that oxygen is always a diatomic molecule or diatomic element, which is O2. But our exam guidelines restrict us just to look at the combustion of alkanes. So you know that you start from methane, ethane, propane, butane, pentane, hexane, heptane, and octane. So those are the alkanes that we are going to look at in terms of combustion. And we know that as we're looking at the different combustion reactions, we know the product that we are always expecting. Then we also look at esterification. Some of the schools use esterification as one of our prescribed experiment where we're using alcohols, which are primary alcohols. I would always emphasize this, primary alcohols. And you know what do you mean by primary alcohols by now, even though I never talked about it. Primary alcohols whereby the functional group is bonded to one other carbon. Secondary functional group bonded to two other carbons. Tertiary functional group bonded to three other carbons. Those are the ways that you definitely need to remember. As I said that when I was providing you with the terminologies, some of the terminologies I never included, but they are also very important because they can also be part of your examination. Therefore, we know that as you are going to use alcohols and carboxylic acid, you are going to form an ester. And we know that our ester that we are going to form, water will be removed as one of the byproduct or as an inorganic product. So it is very important to remember how did we do combustion, how did we do esterification. And then we also looked at addition reactions. I also said addition reactions will only be done for the alkenes. The alkenes are the only compounds that are going to undergo addition reaction according to our syllabus. So you know that when you add a hydrogen, or when you add water, or when you add a hydrogen halide, or when you add a halogen, you must know the product that you're going to expect at the end of that reaction. So we know that when we add a hydrogen, we will expect a alkane to be formed. Why? Because we know that we are going to move from an alkene whereby a double bond will be broken, and definitely because alkene is unsaturated, a saturated compound will be formed. So when we add a hydrogen, we are going to get a saturated alkanes, which is a product that will be formed during hydrogenation. So addition of hydrogen is hydrogenation, and the product that we are expecting is an alkane. And then when we add water, the name of the reaction is hydration, as it is provided here, and we expect to get an alcohol from that alkene. So when you take water and you add it inside an alkene, we are expecting to get an alcohol, and the name of that reaction is hydration. When you add a hydrogen halide, I use HCl and HBr because those are our halogens that are stipulated by the exam guideline for you to understand in terms of these reactions. So if you use HCl or HBr, you know that is hydrogen and halide, so it's hydrohalogenation, and we expect a haloalkane, but you must be mindful of that haloalkane. If you are using a hydrohalogenation, you know that a haloalkane that is going to be formed will have one halogen. However, if you are using a halogenation like Cl2 or Br2, we are adding it in an alkane, you are going to also get a halogen, but a haloalkane, but that haloalkane is going to have two halogens. So it is very important that when you see a halogen with two halogens, not a halogen, a haloalkane with two halogens, you definitely know that this was formed during halogenation. But if that halogen is having a one halogen, or a haloalkane is having one halogen, because I'm just misusing the word halogen instead of haloalkane, you know that it is coming from a hydrohalogenation. So you need to know how was that specific product being formed if it comes from an addition reaction like this example. So hydrogenation is the addition of hydrogen in an alkene. Hydration is the addition of water in an alkene. Hydrohalogenation is the addition of hydrogen halide. Let me just write hydrogen halide, which is a hydrogen and a halogen. Hydrogen halide in an alkene, and also halogenation, which is an addition of a halogen in an alkene. So you know that all the addition reactions will be undergone by the alkenes. Of course, the alkynes can also undergo addition reaction. However, our syllabus is only limited to the alkenes. Therefore, you will definitely know that whenever an alkene is undergoing a reaction, you will definitely expect that alkene to undergo addition reaction, because we also don't do elimination reactions of alkenes. Only addition reactions of alkenes will be examinable, but you need to know what is it that we have added in that specific alkene. Now, let me just remind you in terms of combustion reaction, because what is important here is that you remember how do we balance equations in terms of combustion reactions. Let me take maybe the third alkane, which is propane. Propane, we know, according to the general formula of alkanes, is CnH2n plus 2. So if it is C3, it's going to be H2 times 3 plus 2, which is going to be C3H8. I'm just reminding also in terms of the general formulas of different homologous series, so that you can also identify them as a homologous series. So if I'm having C3H8, I'm going to react it with oxygen, which is O2. And I know that I'm always expecting to find carbon dioxide and water. So this is the pattern that I'm going to use always when I make an alkane to react with oxygen, so that I can use the method that I discussed in our previous lesson. Now, we know that it's going to be alkane, oxygen, carbon dioxide, and water. Now, here we are having 3. So this number 3, we are going to put it here. 3. And then we will say, what is the number that follows 3, which is going to be 4. Why are we doing this? We are trying to balance the number of oxygen on the right-hand side, so that we can divide them by 2 to get the number of oxygen on our left-hand side. So it's very difficult to balance these oxygens here. So this is the method that will assist you to balance the oxygen. So it's going to be 3 times 2, which is 6. And then 4 times 1. Remember, there's 1 here, which is 4. So how many oxygens do we have this side? There are 10. And then we are going to divide them by 2, and then we are going to get 5. So the 5 that we are going to get this side, we are going to put it here to balance the number of oxygen on your left-hand side. And after that, you will check whether your equation is balanced. There are 3 carbons, there are 3 carbons balanced. There are 8 hydrogens. 4 times 2 is 8. Hydrogens are balanced. 5 times 2 is 10. 3 times 2 is 6. Plus 4 is 10. So our equation is balanced. So it is very important to remember, how do we use this method? You just balance the number of oxygen on your right hand side, so that you can divide that number by 2 and get, let's use an even number like C4H10, which is a butane plus O2, to give us what? Carbon dioxide and water. Now we are saying the number here is 4, so we're going to put 4 here. And then what is the number that follows 4? Is 5. So we already have 4 and 5 this side, and then we have 4. So we're going to count the number of oxygen this side. The number that we're going to get, we're going to divide it by 2 and put it here, so that it balances the number of oxygen on your left-hand side. So it's going to be 4 times 2, which is 8. 5 times 1, which is 5. 8 plus 5 is going to give us 13. So we're going to get 13 divided by 2. Remember, 13 divided by 2 will give us an improper fraction. Therefore, it means now we have what we call, we have 13 divided by 2. but we know that we are not allowed to divide with a fraction. So we must remove a fraction so that we can end up with whole numbers. So what is going to happen is that we will need to remove these 2 here. So what do we do? For us to remove these 2, we multiply everything by 2. So it means it's going to be 2C4H10 plus 13O2, giving us 8CO2 plus 10H2O. This is exactly how we are going to balance our, but make sure that the way I wrote it in terms of alkane, oxygen, carbon dioxide, and water pattern, it also follow exactly like that, so that you can use this method of one number following each other in order to balance the other number. So this is the strategy that we have used previously to balance our combustion reactions, because for balancing we will always be provided or awarded 1 mark. So that 1 mark, we can easily get it by using this strategy in order for us to balance. So just try with all the other alkanes so that you can see whether you can balance all the 8 alkanes according to the exam guideline. Then esterification, as I said, esterification is the reaction whereby we use primary alcohols and carboxylic acids to get an ester in water. And we also know that for this reaction of esterification to occur, we need sulfuric acid as one of the catalysts for the reaction to occur. So it is very important to know the reaction conditions for every reaction that you are going to use. For example, if we, let's say we are having a methanol, which is H3OH. Let's say we make it to react with ethanoic acid. We know that the structure of ethanoic acid, we can draw it as CO, let's say ethanoic acid, CH3, just like this, OH. However, when you are making esterification, I think it is very important that you flip your acid, because always the name will start with the alcohol and end with an acid. So just flip your acid so that the functional group of an alcohol and an acid face each other in order for you to be able to remove water. So it means I will write it as, and then it's going to be H, and then C double bond O, and then CH3. What I've done, I've just flipped this structure. I've just flipped it. Therefore, it means now I will now take the hydrogen from this exit as a proton donor and an OH from the alcohol. And then this will be H2O, is going to be one of the inorganic products that will be formed. And I know that for these to occur, definitely I will need what? H2SO4, which is concentrated. Sulfuric acid, which is concentrated, for me to undergo esterification. Therefore, what is going to be left after I've removed water is going to be CH3, which is going to be our methyl, and then it's going to be C double bond, where is it? Oh, there's another O that I think I've missed here, is CO, yeah, COOH, yeah, COOH. So remember, I've removed water, so there is an oxygen. Let me just remove this one. There is CH3, and then there is this O that is coming from a carboxylic acid, and then C double bond O, and then CH3. So this is my ester and water. Remember, water is one of the inorganic product that was formed. So this one is a methyl from the alcohol, and this one is going to be our ethanoate from the carboxylic acid. So the name of this ester is going to be methyl ethanoate from methanol and ethanoic acid. But remember, the condition is that a concentrated sulfuric acid, which is a strong acid, must be available for this reaction to occur. So I just wanted to remind you on how did we do our esterification in terms of making sure that the 2 functional groups, which is the functional group of carboxylic acid, which is COOH, is and then is always on the same side with COH of the alcohols, so that you can be able to remove a hydrogen here and remove an OH here for you to form an ester. I always flip it when I do it in a reaction. Under the elimination reactions, we know that we are always going to get an unsaturated compound, which is mostly alkenes. So it is very important that whenever you see one of the product being an alkene in a reaction, you must know that that specific reaction is undergone elimination. And we have different types of elimination reactions. Whatever that we have added as our addition can also be removed. And when everything is being removed, we are undergoing elimination. Like when you add hydrogen, it's going to be dehydrogenation. Dehydration for water is going to be removed. Dehydrohalogenation for hydrogen halide, and also dehalogenation for halogens as they are removed. So addition reaction and elimination reaction are opposite of each other. Now you need to know that only saturated compounds now will undergo this elimination reaction according to our syllabus, which are alkanes, alcohols, and yellow alkanes. They're the ones that are going to undergo elimination. And we know that if maybe I'm having a butane, which is my alkane, and it's saturated, and it undergoes elimination reaction, I will expect to have an alkene as one of the products that is going to be formed. So what is going to happen here is that if this is a butane, the alkene with 4 carbons is butene. So the issue is now, where do I eliminate my hydrogens so that it's either I know whether I will form but1 in or but2 in, meaning that it means I will look at carbon number 1, it's having 3 carbons. Carbon number 1, this side is also having 3 carbons. So it means the only carbons that are having few carbons are carbon number 2 or carbon number 2 from each side. So it means if I have to eliminate hydrogen, I will eliminate hydrogen from these 2 carbons. Therefore, the product that will be formed will not be but1 in, but it will be but2 in for that reason, because I cannot touch carbons, or I cannot eliminate from carbons with many hydrogens. I will always look for the carbons with fewer hydrogens. So it is very important that always when you do elimination, you know exactly where do you eliminate. Sometimes we eliminate where there are substituents. Then the conditions that I also wanted us to discuss in terms of these reactions are substitution conditions and elimination conditions, because substitutions and elimination conditions, they are very close to each other. So sometimes they can cause confusion. Substitution, you will always need mild heat, and you'll need a diluted strong base for the reaction, especially like hydrolysis, whereby you move from yellow alkanes to alcohols. However, for elimination, you will need heat, or you will need concentrated strong base. So the examiner sometimes will give you the conditions. You need to know what are you expecting as the product. So if it's elimination, the examiner maybe will give you a concentrated sodium hydroxide or a concentrated lithium hydroxide. You know definitely that that specific reaction is going to be elimination. But if they give you diluted strong base, you will know that that reaction will be substitution. Then we know also that when we have addition reaction, we can add a concentrated acid, or when you have also hydrogenation, we can add a catalyst. So those all conditions are provided to you on your textbook and also on your exam guideline. You can go through them and check what are the conditions. But this one, I just specifically gave them because they are very close to each other and they can sometimes cause confusion. Diluted strong base, substitution, concentrated strong base, elimination. We also look at rates of reactions. We know that under rates of reaction, we define the rate of reaction, which is also provided on your exam guideline. And we also look at the factors that affect the rate of reaction. I think all the factors that affect the rate of reaction are stipulated to you on your exam guideline. Make sure that you know all the factors and how does each factor affect the rate of reaction using the collision theory. As you know that temperature will affect the rate of reaction by increasing the average kinetic energy of particles, concentration increasing the number of particles, and catalyst providing the alternative pathway. So you know it is very important that collision theory is always used in terms of us explaining how does each factor affect the rate of reaction, because we are making sure that at the end of the reaction, the rate of reaction must increase, because we are looking at the increase in the rate of reaction. That is why here we also refer to the positive catalyst. So go through whatever that we have talked about in terms of the factors that affect the reaction, and also use the collision theory to say how does each factor going to be affected in terms of this reaction. We also look at the equilibrium. We defined a closed system. We also define a heterogeneous and homogeneous equilibrium. And we know that when we are talking about the closed system, we are talking about the system that is isolated from its environment, meaning that the reactants and the products cannot go out. But if it's an open system, it means that system can interact with its environment. So it's closed system and open system. Heterogeneous equilibrium is when we are having different reactants and products that are in that reaction, which are having different phases, but if they are having the same phases, is homogeneous equilibrium. We also use Le Chatelier's principle to explain the equilibrium position, and we know what we mean by the equilibrium, the state of equilibrium or equilibrium constant. And then we calculated the equilibrium constant, which we abbreviated as Kc, and we knew that Kc, as we were calculating it, didn't have any unit. So look at those examples where we calculated Kc. We used stoichiometric calculations by calculating Kc. But it is very important that as we are going to use Le Chatelier's principle, you always know what will happen to a product and the reactant. And we use abbreviations like intimendo, hexometro, in terms of the endothermic and the exothermic reactions. You can go back to those videos and try to check what is it that we've discussed in terms of how will the temperature affect the chemical equilibrium, because chemical equilibrium is always affected by temperature only. And then we applied stoichiometry, and I said, and then we use Le Chatelier's principle in terms of the shifting in the equilibrium position. Then the last topic that we did together under the chemistry or paper 2 was acids and bases. In terms of the acids and bases, we looked at Lowry-Bronsted and Arena's principle. I think you can feel that when we were dealing with organic molecules, we spent some time, because remember, organic molecules is 3 in 1. There are all 3 questions with one concept. So it definitely needed us to go back and try to remember what we have done. And the topic was done early in the year. So it might happen that most of the concepts we have already forgot about them. So we had to go back a little bit and revise thoroughly in terms of those. However, this one, because it's the current topic that we have done, most of the things we are still in a position to remember them. So we talked about Lowry-Bronsted and Arena's principle. And I also explained that these are the principles that are going to govern our acids and bases that we are going to talk about, and all the reactions of acids and bases that we are going to talk about. We know that Lowry-Bronsted said an acid is a proton donor, a base is a proton acceptor. Arena said an acid is a substance that produces a hydrogen ion or produces a hydronium ion in water, and a base is a substance that produces a hydroxide ion in water. And then we identified acids and bases as strong and weak, and we also gave definitions of strong acids and weak acids, whereby we classified strong acid as acid that ionizes completely in water to form a high concentration of hydronium ions, and a base, it dissociates completely in water to form a high concentration of hydroxide ions in water. That is very important, because as you put an acid in water, you will expect for that strong acid to produce a high concentration of hydronium ions. However, if it's a weak acid, it means it will ionize partially in water, and it will form a low concentration of hydronium ions. Also, with a base, it will dissociate incompletely to form a low concentration of hydroxide ions. So those are the terms that we definitely have to remember as we are doing acids and bases, and as we are revising acids and bases. We also explain what we mean by concentrated and diluted. Remember, concentrated and diluted is with the proportion of water of that acid and a base. If there is more water than an acid, we say that acid is diluted. If there is less water than an acid, we say it is concentrated. As also in terms of the bases, more water, diluted base, less water, concentrated base. So you need to always know that if you are saying it is concentrated, you mean therefore there is more of an acid than water. And if it is diluted, there is more water than that acid. I also explain how do you do dilution of an acid by pouring an acid into water and not vice versa. We We also look at the term monoprotic and diprotic acid as according to Lorentz-Bronsted, when the Lorentz-Bronsted theory said acids are proton donors. And then it means now it can also be classified further to say how many protons can that specific acid donate. If an acid can donate 1 proton, we refer to it as a monoprotic. If it can donate 2 protons, we refer to it as a diprotic. And we also look at different examples, like for example, if we have HCl, we know that this is going to be an example of a monoprotic. However, if we have H2SO4, this is going to be an example of a diprotic acid, as the number of hydrogens that acid comprises will make it to donate those number of acids. We identified acid-base conjugate pairs. We know that the difference between the acid and its conjugate base is 1 hydrogen, as we explained. And we know that the difference between a base and its conjugate acid is also 1 hydrogen. So always make sure that when you are given a question, you check whether which one is having more hydrogen. The one that will have a more hydrogen will be an acid in that pair of acid-base conjugate pairs. We use some stoichiometric calculations. I hope we can also be able to do one example today. As I'm looking at the time, I think we will manage. And then we use stoichiometric calculations to calculate the concentration of an acid, or the number of moles of an acid, or the volume of an acid or base. We also use calculations using pH of strong acids and bases. And I said you must always make sure that you copy the pH formula correctly from there. Data sheet, which is pH is equals to minus log the concentration of H3O plus, which is provided to you on your data sheet. So you must make sure that always when you copy this formula, you copy it correctly. And also pH do not have units just like Kc. So always when you calculate pH, we are not expected to provide units. And then we also talked about the meaning of Ka and Kb value. This was used to compare the strength of different acids and different bases. And we know that if Ka value is greater than 1, it shows that that acid is a strong acid. And then if it is less than 1, it's a weak acid. And then if Kb value is greater than 1, this one is a strong acid. And this one is a strong, not stronger, strong base. So as the examiner sometimes can provide you with the Ka value, you need to be able to relate that Ka value as an acid being a strong or a weak, and immediately remember the definition of strong acids and weak acids so that you can use that information in answering your questions. Like, let's look at this multiple choice question, because we've been talking since, like, for acids and bases, because I know that some of us felt that this was one of the topics that was not given a thorough attention or enough time, because it was done towards the end of our June exam. So we need to just remember some of the concepts that we have done. Dilute nitric acid is added to distilled water. I think we know that nitric acid already, as you know it, is an example. HNO3 was provided as an example of strong acid. So as you are adding nitric acid in water, the first thing that you have to think about is, will nitric acid ionize completely or incompletely? So as it was identified as one of the common acids and was identified as a strong acid, we know that it will ionize completely in water. And what will happen to the concentration of the hydronium ions that will be formed? We know that that acid will ionize completely to form a high concentration of hydronium ions. So we are always expecting strong acid to ionize completely and to form high concentration of hydronium ions in water. Therefore, how will this affect the hydronium ions concentration and the ionization constant Kw at 25? Kw at 25 degrees, we know that it is going to remain constant. It's not going to change, because it will always be affected by the temperature. But at 25 degrees Celsius, it will remain constant, or 298 Kelvin, it will remain constant. Therefore, what do we know about hydronium ions concentration? According to strong acid, they ionizes completely to form a high, it's form, not from, a high concentration of hydronium ions. Therefore, we expect this acid to ionize completely in water to form a high concentration of hydronium ions. Let's look at the options. Yes, we agree that the concentration of hydronium ions will increase, but we know that the Kw value will not increase because the temperature is the room temperature, which is 25 degrees Celsius. So option number 1 is incorrect. Here, already we know that this cannot be an option because the concentration of hydronium ions cannot remain the same. It's a serious distractor. However, these three can be the distractors that we can look at because they are all agreeing that the concentration of hydronium ions, the high concentration of hydronium ions will be formed as the acid ionizes in water. But the concentration of the ionization constant will not increase, will not decrease, but it will remain the same. So it means our correct option is C. Here is correct, it will remain the same, but it is also saying the concentration of hydronium ions will remain the same, which is not correct because this is a strong acid, it ionizes completely, and it will form a high concentration of hydronium ions. Let's look at this one, which is number 2. Consider the ionization of reaction 1 and 2. We have H2PO4 minus plus water, giving you H2O plus X. And then we have X in reaction 2, reacting with water to give you H2O plus Y. So immediately when you look at the reaction 1, you can see that this reaction 1, what is going to happen? You need to identify your acid and a base. We know that if you look at this reaction, water cannot be classified as an acid or a base. We know that water can act as an acid or a base. It's an ampholyte, so it can have the dual functions when it reacts with an acid or a base. But when you look at this reaction, you can see that this H2O changed to be H2O plus. So it means water here accepted a proton from where? From H2PO4. So it means our X here will become H, then PO4 2 minus, meaning that this is a conjugate base of this acid, as this one is going to be identified as our acid and this one is going to be our base. So this one is going to be our acid this side and this one is going to be our base. So already we know that X is our is HPO4, which is a base here. So we know that is HPO4 2 minus here. Therefore, if we are also having water here, it means water also accepted a proton here and it became H2O plus. So therefore, it means this Y now is going to be PO4 3 minus. It means it started having, so it means this compound started being H3PO4. It lost one, it became H2PO4 minus. When it loses the other one, it becomes HPO4 2 minus. When it loses all the protons, now it's going to be PO4 3 minus. Immediately when you lose one hydrogen, you will add a minus in terms of the number of ions that are being lost. So this is the triprotic acid, which is not examinable, but we can see that it moved from this point to this point. So we need to identify X and Y. Yes, we can agree here and here, PO4 2 minus, we can agree here and here, but this one is a total distractor. Then we go to this side. Yes, we have agreed that this one is correct. This one is not correct because it was an initial. This one is correct also, but this one is incorrect. So you can see that the one with both correct answers is number A, which is our option. So this question was actually looking at the concept of conjugate base as a conjugate acid base pairs. So those are the things that you must definitely remember as you are going to your examination. Let's look at this question. As I said, I wish we can do one question on acids and bases and the calculations so that we remember what we have done and the stoichiometric questions. Two acids, X and HX and X or HY, of equals concentrations, they're saying their concentrations is the same, are compared. The pH of HX is 2,7 and the pH of HY is 0,7. What do we know by pH? We know that pH ranges from 0 up to 14, whereby 7 is neutral. So we know that this side is the side of acids, This side is the side of bases. This one is neutral. So we know that acids are stronger closer to 0. The side is strong acids, and then they are weaker towards 7. And then bases are weak from 7 towards 14, and then they are stronger somewhere here. So already, if you compare the two acids, HX and HY, you can see that now we compare these two numbers in terms of the pH, 2,7 and 0,7. You can immediately say HX is weak acid as compared to HY. They are both strong acid as you can look at them with their numbers, but the strength is also different from each other. So that makes HY to be stronger than HX. So HX is our weak acid and HY is our strong acid. How did you find that out? We find that out by looking at their pH, because the pH range can also identify whether the acid or the base is strong or weak. Now, what do we know about strong acids? We know strong acids ionizes completely, weak acid ionizes incompletely. And we also know that as we are saying strong acids ionizes completely, the concentration of those acids will be the same as the concentration of the hydrogen ions because they ionize it completely. Therefore, the first question says define lauryl-prostate acid. Therefore, is 2 marks. We know that according to lauryl-prostate, an acid is a proton donor. This one I expect everyone to get because it's a recall question. The second question, which acid, HX or HY, is strong? Give a reason for your answer. What will make us to say which one is stronger? As I said, we look at the pH value. So as you compare HX and HY, you can see that HX is 2,7 and HY is 0,7. So which acid is stronger? So it means our stronger acid here is going to be our HY. Why? Because it is having a lower pH. Or we can say it will ionize completely. Remember, immediately when we identify it as stronger, we already know that it will ionize completely. So HY is our stronger acid because of that pH, which is 0,7 as compared to 2,7. As you compare the numbers, you know which one is the smaller number. Then acid HX, which we have identified as our weak acid here, ionizes in water according to the following reaction: is HX with water, giving you H2O plus and HX minus. So you can see that this is a conjugate acid of this base. This is an acid, and this is a conjugate acid of this conjugate base of this acid. And then this is a base, and this is a conjugate acid of this base. Because this was formed from this one, was formed from this one, and this one was formed from this one by accepting a proton. Therefore, the Ka value of this is given as 1,8 times 10 is 1,8 times 10 to exponent minus 5, which is 0,0000018. It's a very big, it's a very small number. So immediately when you see this Ka value, what comes into your mind? Remember, we said when the Ka value is greater than 1, means it's a strong acid. But if the Ka value is less than 1, meaning that it's a weak acid, this one is a strong acid. So already by ionizing to this Ka value, it shows that this HX is our weak acid. Now, when it's our weak acid, what do we know about weak acids? Weak acids ionizes incompletely to form a low concentration of hydrogen ions in water. Now, the question is the concentration of hydrogen ion higher than, lower than, or equals to the concentration of HS? Give a reason for your answer. As we have identified our HS as weak acid because of the Ka value, what do we know? We know that it will ionize incompletely, meaning that it will form a lower concentration of hydrogen ions. Therefore, it means the concentration of hydrogen ions will be lower than that one of HX because it will not ionize completely. And then they say give a reason for your answer. You can say it's because it is having a Ka value which is less than 1, or it ionizes incompletely to form a low concentration of low concentration of H3O plus. These are the definitions that we got as we're explaining what do you mean by strong acids, weak acids, strong bases, weak bases, and we know how do they behave as they ionize in water. So it is very important that you see what the examiner is giving you, because definitely the examiner will give you a clue on what are you going to use in order to obtain the answer that is required. Then let's look at this documentary question. Learners add 150 cubic centimeter of sodium hydroxide of unknown concentration to 200 cubic centimeter of what? Of hydrochloric acid. And you can see that now our hydrochloric acid is provided with a concentration. So it means this is our standard solution. Remember, standard solution is the solution of known concentration. So we don't know the concentration of sodium hydroxide. We know the volume of sodium hydroxide that was present, that reacted with hydrochloric acid, but we don't know the concentration that reacted. But when you look at this, we know that the concentration is provided in mole per decimeter cube. So immediately when you are given cubic centimeter, I will always advise you to divide those cubic centimeters with what? With, you change them to make them a cubic decimeter. You say 150 divided by 1,000 so that you can find the decimeter cube, which is going to be, we can use our calculators, which is very important, which is going to be 150 divided by 1,000. And then we go and I get 0.15 cubic decimeter, and also 200 divided by 1,000, which is going to be 0.2 cubic decimeter. So already when you have your cubic decimeter, you are working with the correct volumes, you are working with the correct units of volume according to your concentration that you are provided. Now, they are saying that they find that the pH of the solution is 2. Assume that the volumes are additive, meaning that as we are going to make these two react in this beaker here where the pH is 2, it means the volume now of an acid and a base is added because they have already reacted together. They are both inside the beaker where we find the pH as 2. So it means that our volume here is going to be 0.15 plus how much? What is it? This one is 200, 0.2, which is going to be how much? Let's see. So already we know that our 0.15 plus 0.2. So we know that the volume here now, our volume here is going to be 0.35 cubic decimeter, because they said our volume is additive in the beaker where the two reacted. Now, already we know what is the concentration of an acid that reacted with the base here, but we don't know the concentration of the base that reacted with the acid. And here we know the pH, which is 2. The pH 2 indicates that the acid that is here, this solution is acidic. pH 2 shows already that this solution is acidic. So the acid that is here is a strong acid, showing that this pH, that makes that pH to be 2. Therefore, the first question says, calculate the concentration of H3O plus ion. We already have the pH we are provided in our solution, and we want in the final solution, and we want the concentration of H2O plus. So we know we can use the formula pH is equals to minus log the concentration of H3O plus, whereby our pH is provided as 2, and then we know that we can change this. Okay, our pH is 2, yes, let me just put this, and then minus log H3O plus. You can easily say the concentration of H3O plus mathematically is going to be 10 to exponent minus pH, which is going to be 10 to the exponent minus 2. And then when you use your calculator, I think you're going to get 0.01 moles per decimeter cube. You just use your exponent to find that as your pH. Then after finding the pH, we know that hydrochloric acid is a strong acid and it ionizes completely. Therefore, if you know the concentration here at the final solution, let me just go to the next. If you know the concentration here of H3O plus in our final solution as 0.01 mole per decimeter cube. We already know the concentration of HCl. Why am I saying that? Because we know that HCl is a strong acid and it ionizes completely. So we know the concentration here at the final solution of HCl. And we already know the volume, which is 0.35. So we can know the number of moles of an acid at the final solution, whereby we're going to say at the which is the excess acid, whereby we're going to say HCl excess is going to be, number of moles of HCl is going to be, remember, C is equals to N over V, whereby N is going to be equals to CV. So it's going to be C, which is going to be 0.01 multiplied by 0.35. Remember, the volume is additive. So we're going to find the number of moles of an acid here, which is going to be 0.01 multiplied by 0.35, and it's going to give us 0.0035 moles of an acid that is in excess. Therefore, if you know the number of an acid that is in excess, we know the initial acid that reacted, which is going to be, we know the volume and the concentration of an acid that reacted, which is going to be N is equals to CV, which is the initial one, and it's going to be what? 0.03 multiplied by 0.2. And then we're going to get the initial number of moles of an acid. Our time is up already. I hope I will just do this one just to show you how do we arrive to an answer, which is going to be 0.03 multiplied by 0.2. And then we're going to get 0.006 moles of an acid initial. So for us to get the number of moles of an acid that reacted, which is going to be the one that reacted with this sodium hydroxide, is going to be the initial, which is 0.006, subtract the excess, which is 0.0035, and we're going to get the number of moles of an acid that reacted, which is 0.0035, which is going to be 0.0025 moles. So remember, this number of moles are the ones that reacted with sodium hydroxide, and the ratio of sodium hydroxide and an acid is 1:1. So if you know the number of moles of an acid, we already know the number of moles of what? Of sodium hydroxide. So it's going to be 0.0025 moles, if my calculation is correct according to the calculator. Therefore, to find the initial concentration of sodium hydroxide is going to be the number of moles multiplied by divided by the volume, which is going to be what? The number of moles is 0.0025. The volume of this carbon dioxide was of sodium hydroxide was provided as 0.15. Therefore, you're going to find the concentration of sodium hydroxide that reacted initially with a hydrochloric acid. So my learners, I hope the time is up now, but I hope whatever that we did today, we tried to cover up whatever that is going to be expected of us on Monday. So make sure that you go back, you revise your work, and make sure that whatever that is needed in terms of the calculations and the recalling of information in terms of definition, you make sure that you go through such information. We have come to the end of today's lesson. I hope this lesson assisted you or will assist you to initially start your revision for Monday. As you are going to start tomorrow writing your paper 1, you are now motivated at least to go to your Monday paper with an information that will definitely assist you. With so saying, I would like to say, make sure that you always sanitize, wear your mask, and make sure that you keep also social distancing as we are still on COVID. And with so saying, I would like to say thank you so much until the next lesson. Goodbye from my side. Thank you.